All right, so how do children begin to actually figure out the value of addition? So sometimes they'll learn that 1 plus 1 is 2 or 3 plus 3 is 6, but really before then, they need to understand how to figure out those values from working with very, very small numbers. So there are generally 3 levels of addition, single digit addition that students go through. And some students will go through that linearly, some students won't. But generally, just to help us kind of orient ourselves around how children add, it's helpful to think of these 3 levels. So direct modeling, or count all, is, for example, if we use the example 3 plus 8, is going to be kids actually writing out 3 and 8 and counting from the very beginning. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So they will say that there are 11 pieces here. So 3 plus 8 is 11. So they're modeling the 3, they're modeling the 8, and they're counting all of it. Now, counting on with, for example, 3 plus 8 would be, they would say, well, there's 3, and then I need to add 8 more. So I need to add 8 more. So I can do 3, 4, 5, 6, 7, 8, 9, 10, 11. 11. So they will say 3. They won't recount the 3, but they will say that 3 and then count 8 more. And often they'll use fingers. So they will put up 8 fingers and then count up until they get to having those 8 fingers all counted. Now, with 3 plus 8, there are a couple of ways to count up. There's also a method where you can take the larger number and then count up from that. So for example, let's say you have 8 and you need to count up 3 more. So this would be 9, 10, 11. This is a more sophisticated method because the student needs to recognize that the addition is commutative. In other words, it doesn't matter which order you add. And also the child also needs to recognize that 8 is the larger number. So instead of counting on from the smaller number, they're going to count on from the larger number. So that is levels 1 and 2. So the direct modeling, the counting all, there's absolutely no understanding of the special properties of addition. And then there is the counting on level, where the students understand that the first number or one of the numbers is the place you start, and then you can count on all the additional numbers. All right, so then in level 3, students can begin to use some other facts that they know about addition. And these are just examples for how some of the students might be thinking of this addition. But there are many, many more because kids are flexible and kids are generally quite imaginative about how they can decompose and compose numbers. So, for example, some derived facts could include making 10. So a student could say, well, I know that 3 plus 7 is 10. But I needed to add 8, not 7. So I need to add 3 plus 7 is 10 plus another 1. So what they did was they split 8 into 7 and 1. That's making 10 method. Also, they could say, hey, I like making 10 with large numbers. 8 plus 2 and 9 plus 1 and 7 plus 3. So instead, I'm going to say that I'm going to add 8 plus 3. But look at 3 as 2 plus 1. Then 8 plus 2 is 10, and plus another 1 is 11. So that's very helpful when kids have a good understanding of which numbers make 10. And that's something that comes with practice and things like this, which is 10 frames or rec and recs, etc. Kids also use doubles. So for example, in the 3 plus 8, they might say that I'm going to add 3 plus 3, and then plus another 5. So 6 plus 5, which is actually 5 plus 5 plus another 1. So that's 11. They could easily use doubles, and they do quite a bit, because doubles are easy. Kids love doubles in kindergarten. So let's see what else we can, what kind of questions we can look at. So we did use 3 plus 8 in levels 2 and 3. Let's try 9 plus 4 and 7 plus 5. So 9 plus 4 and 7 plus 5. So making a 10 method. So we know that 9 plus 1 plus 3, we can break the 4 into 1 and 3, will give us 10 plus 3, or 13. That was the one from making a 10 from a larger, just because that was the order in which it was given. Now, in terms of doubles, we can say 4 plus 4, or, right, because we split 9 into 5 and 4, or which is 5 plus 8, which is 13. And they could figure that out in a range of different ways. They could say that's 5 plus 5 plus 3. That's 13. And a 7 plus 5, we could make 10 from, in this case, the larger is first, so it can be from the larger. So 3 and 2. So there's our 10. So that's 12. Or we can do doubles. 5 plus 5 plus 2. So there's our 12 again. So kids can be quite flexible in how they think of these small additions. And notice this is really before they start thinking about place value, and they're simply working with single digit addition. So what property of addition does the count on from larger method rely on? Well, we talked about that. That's the commutative. Because the students need to be able to understand that it doesn't matter whether you're adding 3 plus 5 or 5 plus 3, that the total sum is going to be still the same. Why is the property of addition you discussed in the previous part especially important for lightening the load of learning the table of basic addition facts from 1 to 1 and 9 plus 1 plus 1 and 9 plus 5? So why is it important that it doesn't matter what order we're adding in? Well, when we are learning the table of basic addition facts, I am assuming they're talking about memorization. So things like 2 plus 3, 2 plus 4, 2 plus 5, 2 plus 6, and then 3 plus 3, 3 plus 4, 3 plus 5, 3 plus 6, and then, this would have been 3 plus 2, 2 plus 2, right? So one thing that happens when we know the commutative property is that we realize that 2 plus 3, if we know 2 plus 3, we know 3 plus 2, and it doesn't really matter which one you're figuring out, because the value is going to be the same. So that really cuts down all the addition and subtraction basic facts by half, so that you can only memorize half or have a strategy to solve half. And we'll talk more about the place where memorization stands in mathematics in a little bit later. What property of addition does make a 10 method rely on? Well, what we're doing, for example, in 9 plus 4, we said that's 9 plus 1 plus 3. And we're figuring out the 10. So that's the associative. We are breaking something apart, decomposing something, and then we are grouping two numbers of our choosing, the two numbers that make a 10. Why is make a 10 method especially important? It's especially important because we're looking to building up to place value. And students need to have a very good understanding of grouping and place value in order to be able to work with our number system. What property of addition does the doubles plus 1 method rely on? Explain writing equations and demonstrate how the property is used. Well, if we have a, say, 6 plus 7, we could say that 6 plus 6 plus 1, because that was our 7. So there's the associative. And then we said, well, 6 plus 6 is 12. We know that, plus 1. There's associative again. And then that would be 13. So this is the doubles plus 1 method relies heavily on the associative property. So why does a child need to know the number to add to make a 10, or the partners of 10? Well, if you look at make a 10 method, then this becomes really essential. From questions from 1 to 9. Why does a child need to know that 10 plus 3 is 13 without counting, and know that 13 decomposes into 10 plus 3? Well, that's an important property. Again, now, but also later, when we're talking about place value, composing and decomposing numbers is essential so that we can use properties like, methods like make a 10. And for each counting number from 2 to 9, know all the ways to decompose it as a sum of two counting numbers. Again, that's the same thing where we're looking at making 10 doubles. We are looking at a whole, we need to have students be flexible with composing and decomposing numbers for questions, for numbers between 2 and 9 and beyond as far as possible. Eventually we'll be decomposing based on place value. So for example, we'll say 23 is 20 and 3, but at this point we need to begin that understanding early so that they understand that any number can be decomposed in two other numbers in a range of ways.